And folks, it looks like this is a very full planetarium show. If everyone can move towards the center of the row that they are sitting in, so we can free up some more seats on the edges so that more people can sit with their friends and family, that would greatly help us out. So if you can move towards the center, thank you so much, folks. It looks like we still have more guests coming in, and it looks like it's going to be a very full show. And thank you to everybody moving towards the center. This helps us a great deal. It allows people to sit with their friends and family for the planetarium show. Also prevents people from jumping over you to get to those excellent center seats. All right, everybody, we just got our okay to start our planetarium show, so I'm going to put away our space trivia questions because now, folks, we're heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, good afternoon. Hey, don't hurt your necks. Look forward into the dome before you. Everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors all throughout our room. I just want to let you know that I'm a real person. A lot of people think I'm a robot for some reason, but I'm real. Trust me. And also, folks, I'm really happy to have you here because this final planetarium show of the day is different from all the ones we've done. This one's called Tour of the Universe, and this show is completely live, so you're going to hear my voice for the next 30 minutes, and we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space, but we're pretty small in the grand scheme of things, so just a forewarning. And before we get started, I got to go over some quick house rules, just so that we have a good time in here. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away till the end of the show. We want to keep this place as clean as possible. If you have any cell phones, smartwatches, now is a good time to put those devices away for the next 30 minutes. These are very distracting and takes away from the planetarium show. And also, if you're trying to record, it doesn't look that great on our dome. It looks really fuzzy. We've tried. And also, folks, if you need to leave early during the show, the exits are going to be at the very top of the planetarium, so make your way up the stairs to exit if you need to leave for any reason. And sometimes the stairs is a little bit too steep for some folks. If the stairs are too steep, don't worry, just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit so that you don't have to climb those steep stairs. Just stay seated for a bit longer. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. But with that being said, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. All right, folks, as I mentioned, we're starting off pretty close to the Earth. We can see the curvature of our planet, the city lights down below. But we're going to be starting off at this spacecraft right in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey Christian, what's the International Space Station? I hear about it all the time in news and articles. I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all different types of experiments up here. Some of the experiments they've conducted are things like what happens when you try to grow plants in space? Do the plants grow the same with less gravity? Which way do the roots grow? Another one of my favorites is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently? And one of my favorites is where they had two identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted the two twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have as much gravity working down on you while you're up here in space. So if you plan to live in space for a long period of time, remember to exercise daily. And also, folks, the space station looks really big here in our planetarium, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire museum that we're sitting in, the California Academy of Sciences. That's roughly how big it is. And also, what's incredible is that the International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks really far away from our planet Earth, but it's not too far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip with the family to get away for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans out into space nowadays, only 225 miles above the surface of our world. The reason why is because traveling into space is very expensive. You have to build yourself a rocket ship, buy yourself one, or hitch a ride. And then once you accomplish that and spend all that money, it's also account for all the rocket fuel. You got to be able to escape our planet's, the Earth's gravity. So you have to buy a lot of rocket fuel. And then once you're out here in space, you have to account for all the food, water, all the air you're going to be breathing while you're up here. So the bill gets quite costly quite rapidly. But folks, the International Space Station is just the first stop on our tour of the universe. So now we're going to see it slowly fade away to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it as it slowly disappears. Alrighty, folks, we're now able to see our entire planet Earth all the way out here. And I want to let you know that the space program that I'm using here inside the Morrison Planetarium is something that you can go home and download if you want to fly through space just like how I'm doing. The program that we're using here is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across the link and you can download it, and it's a whole lot of fun. And also, folks, if you want to try something different besides OpenSpace, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you can fly through space without having to download anything, and it's still a whole lot of fun. But in here, we're using OpenSpace. But now that we got a sense of what we're using, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's six Apollo space missions. That brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science. Of course, they had some fun up here as well. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans to Mars, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone how we're going to be figuring out the logistics of that. And what's amazing is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and ice is going to be very helpful because we can melt it, pass electricity through it, and we can separate the hydrogen and the oxygen, and both that stuff's very valuable when you're all the way out here in space, far from home. But again, we humans should be heading back to the moon in the next few years. Look out for any news about Artemis. And folks, when we look up at the moon here from planet Earth, sometimes it feels incredibly close. It feels like we could reach out your arms and touch the moon. But the moon is incredibly far away. It's about 240,000 miles away from our planet. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. So cute. And now, folks, we're going to see the moon and the Earth as they start to slowly fade away, just like how we saw with the International Space Station. And just like with the International Space Station, I want to add some nice planet trails so we can keep track of everything. Because again, space is really, really big. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, is in view. So here comes that sun. Do-do-do-do-do. And folks, the sun is about 93 million miles away from our planet Earth. Whew, 93 million miles. That is a good distance away. But in terms of speed of light, it only takes sunlight about 8.5 minutes at the speed of light to cross that 93 million miles. So not too bad. But this is a great concept to keep in mind, folks, because let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted. That last bit of sunlight will travel that 93 million miles at 8.5 minutes at the speed of light. Then all of a sudden, the daytime on Earth would become nighttime. And again, this is a great concept to keep in mind because let's say you're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's like looking back in time in a sense, which is really cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle of our solar system, we have our star, the sun. Closest planet to the sun, we have Mercury. Then we have Venus, really hot. And then we have Earth. That's us. And of course, we have the red planet, Mars. And then past Mars, we have the asteroid belt. And this is what it would look like if we were to highlight all the asteroids in the asteroid belt. There's about 1 million of them in this region. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Saturn, famous for its rings. And then we have our icy gas giants. We have Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite unlovable dwarf planet, Pluto. So the orbit of Pluto just came on screen, just the very top of our screen right there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And I know a few of you in here are probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Whoa, indeed. So the Kuiper Belt is a second asteroid belt past the orbit of Neptune, and what you're mostly going to find out here are icy asteroids and short period comets that don't stray too far away from the sun. And what's really fascinating is that we came across this stuff back in 2006, and that's when our technology and telescopes improved greatly, so we were able to see much smaller objects much further away. And in 2006, we found more than 400 objects out here in the Kuiper Belt region. Some of this stuff was bigger than Pluto. So we couldn't call all these things planet. There was just way too many of them. So all the astronomers on Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet, and they came up with 3 criteria. And folks, that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of people have hard feelings about that. I still kind of do. But that's the really cool thing about science, because as our technology improves, we're able to redefine and reclassify. So science is constantly updating and changing. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers has not traveled as far as light travels in a single day. In order for sunlight to get all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours, not too bad. But folks, it's time for us to leave our planetary scale behind us, because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri just flew right by us on our top left of our screen. So again, we're right in the center of our screen right here. And on the top left, we have Alpha Centauri, the closest star system to us. And again, 4 years at the speed of light just to get to the nearest one to us, folks. But that doesn't put into perspective of how long it would take us to travel this distance. Well, if you're to get in a rocket ship today, make your way over to Alpha Centauri, it's going to take you about 8,500 years to make that journey. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're stepping inside something called the Radiosphere. And again, we're now inside something called the Radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, and then radar signal, and of course later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate some many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. Oops, sorry there. So again, we found 5,000 exoplanets, and we're constantly scanning the night sky, so that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, as we're starting to swing around, you can see a whole lot of exoplanets in this one direction on the right side of our screen. We pointed our telescopes in that direction for about 10 years, so we found a whole heap there. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being created, developed at the moment, so we got a while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to put away our exoplanet markers. I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. And now, folks, we're looking down on our Milky Way Galaxy. This is the galaxy that we live in. And I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way Galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light to cross it once. This thing is big. And our Milky Way Galaxy is so huge, we estimate that there's about 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave it, I want to show you what it looks like from the side. You're going to notice that our Milky Way Galaxy kind of looks like a big pancake in space. It's really flat. And this is important because when scientists and astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south. Instead of looking through the plane of our Milky Way Galaxy, which has planets, stars, gas, debris, things that block their view of the universe. So again, we like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters. They like to avoid each other where there's very few galaxies or voids in space. So we can see some nice galaxy clustering towards the center of our screen. We can see very few galaxies on the very top left of our screen as well. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now, this picture now represents the closest 30,000 galaxies to us in space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brant Tully, who worked at the University of Hawaii, who compiled this amazing representation over decades of time with others astronomers working aside him. So big shout out to Dr. Brant Tully. I love flying through this map. But now we have automated systems that are mapping even the most distant galaxies. So now we're going to be looking at the large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And by the way, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way? Well, if we were to line up our Milky Way Galaxy, it would run right down the middle of our screen, just like so. So again, we like to point our telescopes galactically north and galactically south instead of looking through the plane. But astronomers still want to make sure that it was galaxies through that plane of the Milky Way. So we have this purple survey here. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet. So it's just a matter of time. And speaking of time, we're running close out of time. So let's continue pressing on, because now we're going to be encountering these really distant, faraway objects known as the quasars. And the quasars are orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. All evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to a large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is at the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back home towards planet Earth. So let's find a nice entry point to all these quasars and galaxies. And this looks like a good spot. So let us make a return trip back to planet Earth, everybody. All right, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to peer into their telescopes and see into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're heading straight for our Radiosphere. And now, folks, we're about to make our way back into our solar system, our star system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt region, and making our way to the third rock from the sun, our homeworld planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And if you want to share this whole show with somebody who was unable to make it today, we have this exact show recorded on the Morrison Planetarium's Facebook page or the California Academy of Sciences YouTube page. So you're more than welcome to share this video with friends and family who are unable to make it. But hey, look at that. We made it back home safe and sound just in time for dinner time, folks. And that's all the time we have for today. Thank you so much for stopping by, and I hope you have a great rest of your day. Make sure to get home safely, everybody.